Hi. Ooh. Now it's working. All right. That was awesome. I love, yeah, as Jack mentioned. My, cool, whatever. So as Jack mentioned, upstairs there is open roaming working on open Wi-Fi. We've got 17 APs up there, and I want to have a conversation with these two fine gentlemen, not just about open Wi-Fi, but about why we're doing it and why we're doing what we're doing here and the tools and everything that make a difference to it. So make sure you try open roaming when you stop by. But first, Mr. Who wants to go first? Jonathan from iBrowse and Jussi from Hamina. What I'm going to do is I'm going to give each one of them a few minutes here just to introduce who they are, because you both have pretty cool stories about what you do. I don't know if the mic's working or not, but something's working. I'll invite you up here and then I'll rearrange chairs. That cool with y'all?
Go ahead and start. Okay. Greetings all. My name is Jonathan Angel. I founded about 15 years ago a company called iBrowse, and we are a hyper-specialized ISP. We deal with hotels. That's who we deal with. And you got a little picture up there that describes technically a little bit what we do. I'll try and interpret that for you if it's not 100% obvious. We have our backbone which peers with other operators on the internet. I know everybody likes to do a cloud of the internet, but actually the internet is lots of different operators that peer between them. And sometimes it works really well, and sometimes it works slightly less well. But on our own network, we've got lots of routers. You know, I think you've probably heard lots about routers this week. Routers of all kinds of different sorts are in our backbone network, and servers for running services. But our focus is on our customers, who are hotels. And hotels, they have rather less infrastructure, and it's our job to keep the infrastructure out of the hotel because it's complicated and dangerous to manage on hotels because they've got lots of people who keep changing. 3 times a day they change, then they stay there for 6 months and they move to the next job. So it's not a very secure environment. So our business is about pulling servers and services out of the hotel and putting them in the network. So you end up with a network in the hotel that's got some routers, some switches, and some Wi-Fi access points, and maybe some telephone endpoints. But that's about it. It's network and a few endpoints. And we try and push as many services down that as we can. So started off doing multi-site VPNs to link up these sites to each other, to their data centers, to their money transaction providers. We've added guest Wi-Fi was a fairly early addition. Telephony, local internet breakout. Internet's useful sometimes. Chromecast to make sure that a guest in a room can see their TV but not their neighbors' TVs. Video surveillance, people like to keep an eye on their hotels. TV is becoming IP-based more and more. And building management systems so the doors open and the lights and the thermostats all talk to each other. So that's what we're about. We're about pulling out the complexity, pulling out the 7 different networks that used to operate with cables and spaghetti all over the place into one very simple, or as simple as possible network. You want to talk?
I don't know. Do I have a choice? Let's see if we have some slides here as well. All right. Yeah. I'm Jussi. I work for a company called Hamina Wireless out of Helsinki, Finland. We've been at it for about 18 months. So what we do is really this. We make tools for people who design wireless networks. Wi-Fi, private 4G, private 5G, things like Bluetooth, low energy, stuff like that. We essentially help you design wireless that does not suck for once. And we kind of we're on a similar mission to these guys here, and we share very much a similar vision with Open Wi-Fi. We try to lower the barrier at many fronts. We just do it for the Wi-Fi design, whereas these guys do it for the Wi-Fi infrastructure. So, lowering the barrier of cost. These shouldn't be like $10,000, $20,000 tools. We drop that to like $300, stuff like that. Same thing with ease of use. It's browser-based. It's super easy to use, super easy to learn, stuff like that. So good wireless should not anymore be the privilege of 200 CWNE certified experts. It should be the privilege of everybody, right? So that's what we do. I am on Twitter, LinkedIn, our company is there. It's a bunch of 40-year-old nerdy guys, yeah, that's what we do. We try to change wireless design, whether private 5G, Wi-Fi, all of that. I mean, that's us.
Great. Are you gonna drive from up there?
Yeah, I could drive.
So okay, hold on. You want to fix the mic issue real quick? I'm loud, but you can't hear me on the video camera, right? Is that the deal? Cool. So what we're gonna do is we're gonna do it a little bit differently because it's more fun for show and tell. If y'all are cool with that, is everybody cool with that? Yeah. So we're gonna talk about problems and then we're gonna show them in real time. And part of the conversation. I guess I'll go to Mike here. Part of the
It's like,
okay.
you know,
Awesome. I mean, pick one. It's cool. Yeah. Good.
You want one of these?
Wireless
I mean, this works.
Wireless microphones. Let's try and have a little fun. Okay. How about this guy? How about no? Yeah.
I can be your translator. You say and then I say.
Silent. Yeah. Okay.
Step up here, man.
That's cool. 0 for 4. All right, whatever. So what we're going to talk about? Will your laptop reach over there?
Yeah, actually. Yeah.
Let's make some changes here.
Yeah.
Just have some fun.
Yeah.
Why don't you sit? Whatever. This is
Wi-Fi to home decoration.
this is great. Now these mics are falling off. Most entertaining session of the day. Cool. All right. So.
Very bad way.
Very good. All right. So a little bit about this, right? So Open Wi-Fi we're trying to figure out ways to make good Wi-Fi more accessible, right? And part of the conversation that we were having yesterday, let me see if we can get you a mic so we don't have to just rotate up here. Part of the conversation that we were having yesterday was about how easy it is to get really bad Wi-Fi and how you get in situations where Wi-Fi access points are very inexpensive, and so because they're so inexpensive, anybody can go grab one, and they can throw it up, and if that doesn't work good enough, then they just go throw up another one, and if that doesn't work good, then they just go throw another one up. And, for the RF nerds, that's really bad. Go ahead. Can't mess it up any more than it's already been messed up. You're good to go. So part of it is that you have these issues where everyone has the same access to really cheap, inefficient equipment, and they just deploy it without putting any proper design in it because exactly like Jussi said, these tools are so expensive, right? It's very expensive to buy a spectrum analyzer. It's very expensive to buy, everything that you need, all the planning tools and everything in order to make bad Wi-Fi good. So I want to ask you, in your experience in the past, what you've seen, either networks that you've ripped out and replaced or issues where you've seen very inexpensive equipment used without proper design and planning. What's your experience with that? What have you seen, and what are your thoughts on that issue?
Maybe like an example from hospitality.
Yeah, come here. Swap them.
All right, example. Do we have those slides on the other machine?
We can replace the slides with these if you're okay.
Can we swap between them? Or is that too hard?
Let's see if we can. You might be pushing it back.
Oh, hey.
So
All right.
Just back like many times.
What? Back.
Back.
Let's see here. So again, the question or the problem that we're talking about is that you've got really inexpensive access points that are out there. Bunch of stuff, bunch of commodity stuff out there. And when you deploy it, if you don't put proper engineering and planning behind it, have you seen it create issues in environments that you've been in?
I almost want to say that it's standard to have bad results. I mean, thinking about some of our customers, there is a kind of fixation that says, we're used to the model of one access point for 4 rooms. Yeah, we've always done that. Well, initially we had maybe 1 per 6, but recently we've done 1 per 4, and that's how we set our budgets, and that's the way it works, and that's where the cables are, and just do it. And sometimes it works, but it's often disappointing. And it often doesn't really show up until real users come in and start using the network. So, picked up a little example, and perhaps we can juggle this one.
On that note, we talked about, one of the things that is the theme of this is the barrier of entry. And when we talk about a barrier of entry for networks, you had made a comment yesterday where you don't see it as a barrier of entry. What do you consider?
There is no barrier to entry. Anybody who can go buy an access point and string a cable together can come into this market and do something. And it'll work. And Wi-Fi is designed to work, and it's designed to degrade. So if it's not done well, performance will gently slide down until it gets to the point where it drops off a cliff and it really doesn't work at all. And that was okay 10 years ago, when at the end of the access points there was a little DSL line, and in any event the DSL line was saturating. But we've got big fibers coming to these sites today, and there is an expectation when you go to a hotel, there's an expectation that you've actually got a good, stable connection without latencies. And
so without having the proper design there, anyone can put it out there. And so you see, to you on this, you've built a fantastic set of tools for the industry, and now you're looking at ways that you can help solve the problem of, if no matter what Wi-Fi you want to deploy, you can go out there and you can use a tool set that's cost effective enough to use for people. Tell us a little bit about what you're doing in that space.
Yeah, I mean, we're trying to take out the rocket science in Wi-Fi design in a few ways. So you just essentially open your web browser, and in 2 minutes you'll be using the full tool. And what I've done here is I've just dragged and dropped. I've dropped in a PDF and used 1 minute for modeling, like saying these walls are drywall, these walls are concrete walls, just clicking the walls on the PDF drawing, and that's it. And now we can actually estimate like how the Wi-Fi will actually work in this hotel, and maybe illustrate some of the typical challenges in the hotels. And it's not just that, it's the whole workflow of designing open Wi-Fi networks. So once we have done the radio design and kind of find optimal configurations and placements and antennas and all of that, with a click of a button, thanks to the APIs in open Wi-Fi systems and partners like NetExperience and all of that, click of a button, we can actually deploy this plan into open Wi-Fi, so that it actually starts the site automatically. It pushes the maps to the management system automatically. It pushes the AP placements. So it's also not just an RF design thing, it's a workflow thing and total cost of ownership. We just try to make everything a little bit quicker, faster.
And that's part of the problem, right? Because at first you don't just have, and we're starting at the very base level, right? From an engineering and design perspective, I think it all starts with engineering. I think you all would agree with that, making sure garbage in, garbage out, right? Start with a good plan, a good design, and start to work up from there. And what you're mentioning about is that that single source of truth, where the design tool becomes that single source of truth, so that whoever's doing the installation, and they don't have to go out there and set the manual configuration of these access points, because they could change it. They could put the wrong channel in, put the wrong channel size in, put the wrong frequency in, whatever it is, and that's ultimately going to affect. Do you have what from moving from design to actual integration? What problems do you see in the industry that can be resolved, and how would you resolve those?
Is that for me? I'm a bit pessimistic about this, because I kind of look at this and say, if your design isn't right, so your access points are in the wrong place, you'll have customers who say, well, can you fix it? And very often you can't really fix it. You have to just tear it out and start again. So it's really spend those extra 2 hours at the beginning and get the design right, and then it'll work well. And you can optimize within that space, but if your access points are in the wrong place, you can't make your access points beam their radio energy somewhere else. It's kind of lost, and you will be with bad performance.
You can, and when you walk down that path of doing it wrong the first time, or someone else doing it wrong, a lot of these networks you've got to rip and replace. Something that's been old, that you have to go in and make it work better than the previous person that was in there. I think that's one of the benefits when we talk about on Open Wi-Fi, we talk about the vendor lock-in component of it and being able to move freely no matter which access point it is, no matter which which controller it is. What do you see from your perspective as a benefit to leveraging a system like Open Wi-Fi in the space that you're in, specifically hospitality, MDU, things like that?
There are two obvious benefits, and I think there's a third one that comes to mind of the benefits of Open Wi-Fi. The first benefit that we see is the telemetry that comes out, the data that you can extract from the access points, so that if you've got it wrong, heaven forbid, it isn't right, the installation didn't happen correctly, you know within a week that it's not right, and you know how bad it is. So you put the brakes on, you say, stop deploying that way, fix the problems, and continue deploying the right way. If you don't have that telemetry, it's going to take weeks, months for the customer feedback to start brewing, the dissatisfaction to start brewing, the pot starts boiling, and it'll explode several months later. By the time it explodes several months later, how many other deployments have you done with the same mistakes? And it starts getting very expensive to go back and fix.
Yeah, and I think that's one of the key points. If you've ever worked in the hotel space, you know that there's kind of two main things that hotel operators are very, very concerned with. One is guest experience, or QoE, quality of experience, and number two is cost. And when you've got a bad experience, that's going to obviously hamper the desire of people to stay and visit the hotel. But from a cost perspective, it's that whole mentality of do it wrong the first time, you're going to pay for it multiple times. You do it right the first time, you're good to go. And it's interesting because I see Jussi in the background. What you're showing off here is the traditional way that people used to design hotel Wi-Fi networks. And I'm assuming just from the crowd here and us being, in a different country than I'm sure a lot of you are, we've stayed in plenty of hotels that have had these design issues. So this is what it looks like. Tell me what you're working on over there, Jussi.
Yeah, absolutely. Now it's getting tough to hold the connector and work with it, but that's fine. Oh, wow! Talk about service. You know, not only the food is here great, but also the service. I can. All right, thank you so much. So what we're seeing here is a typical hotel deployment, right? This is what you're seeing. Would you say most of the time? When you see a hotel where the report is Wi-Fi sucks, do something about it. Is this the typical case? And maybe actually you can talk through the issues here and I can just drive. How about that?
Delegation at its best. Okay, one access point per four rooms. The classic customer fixation.
And in the hallway.
And they're in the hallway. Okay, what does this bring? It brings lots of access points that can communicate with each other very well. And then they've got this thing called a concrete wall between them and the customers. So the signal gets to the customer, usually, but the signal from the next neighboring access point is better. Now, this is obviously a problem on 2.4 gigs, where you've only got 3 non-overlapping channels, and you've got a line of 6 or 7 access points that can see each other quite well. It means your capacity is going to be much reduced, because when one access point is transmitting, the other access points on the same channel in the same space can't transmit at that time. So you're really dividing your throughput horribly. So that's one of the issues you face. Historically would have said at 5 gigahertz, plenty of channels, not a problem, it'll work, but we're kind of coming from this perspective and saying you have to design for the worst case. And the worst case for us is your DFS is detecting radar. It may be real radar, it may be false radar, but your DFS is detecting it, and from a regulatory perspective, your access point has to switch channel. If your access points are switching channels, I don't know experience you've had, but we have an experience that says some customers, some of their clients won't switch channels with you. You'll leave them stranded on the old channel, and all they can tell is, I don't understand, but my Wi-Fi keeps hanging. And that's all they'll tell you. you have to dig to find out that it's a DFS event.
And you mentioned the telemetry, and along this, there's a lot of design that's built around absolutes. This is what's going to happen with the customer. This is how they're going to perform when they're there. That doesn't seem like it's a good use case for design.
No, of course not. You want to design your network so that you say, okay, if this site is a DFS, is a radar site problem, I may have to accept to deactivate the DFS channels and just use the basic, uniband channels, which is a limited number of channels, and operate my 5 gigahertz, which means that you have the same problems on 5 gigahertz that you had on 2.4 gigahertz. A small number of channels, they were interfering with each other down the corridor, and so you've really got a design which isn't very nice. It's not very easy to make work, and the throughput that you expect to get from it is quite modest when everybody's working at it at the same time. When you do your tests, as you do the install, it works fine until these things called customers turn up and start using it, and it doesn't work so well.
So the reason we're putting emphasis on this, right, is because we talk about overall lowering the barriers to get into good Wi-Fi, getting into good, decent Wi-Fi. And a lot of that has to do with the original design. So what we've shown off upstairs is on the open Wi-Fi side with access points that are there. You can still leverage the commodity cost of those access points, of that equipment that's out there. It's high caliber equipment. It's manufactured from a lot of the same ODMs that manufactures for some of the other groups in the world. So the equipment is there, the capability is there. I mean, there was a recent release we had last week where someone talking about open Wi-Fi said that it cuts the cost by about 60%. And so when you think about a deployment in a hotel, how many hotels do you all manage, more or less?
A little over 1,000.
How many APs do you think total are out there?
We don't manage all the APs on all those sites, but typically you're looking at anywhere from 15 to 150 access points in a property.
Yeah, so you're talking thousands of APs, tens of thousands of APs. And if we can cut the cost by 60%, and still give people what they want, which is that really inexpensive equipment that they can deploy. And now we have tool sets that allow the engineering to be done correctly. What we've done is we've taken that barrier of entry to good functional Wi-Fi, and we've moved it down through the floor. Just in the last few minutes, in 60 seconds or so, you've seen what Jussi's been able to do with the tool.
Yes, but Jussi's having to add more access points. And more access points traditionally means more cost, which means going over the customer's budget. And that's where the open Wi-Fi is coming in lowering the unit cost of the access points.
Correct.
So that we can actually come back and implement the designs we want to implement.
And that actually, just fun fact, that's the 6th floor of the NH hotels in downtown Prague City that Jussi and I were at last week. And they had terrible Wi-Fi. So we did a free redesign for them, I think Jussi did. But the whole concept is that when you start to look at what tools are out there to help lower the barrier of entry for good Wi-Fi, because it's not just lowering the barrier of entry for Wi-Fi. As you mentioned, anybody can go buy a Wi-Fi. It's what are you doing to make sure that it's cost effective in a way that makes sense. And I think, as you said, that hits home, especially to someone like you who's deploying thousands of these, because is your model where the customer pays you for the equipment, or are you a managed service provider or a network service provider where I don't care what you use as long as it works, that's what I pay you for?
We're changing. We used to be, we sell you the equipment. And we used to find that the commercial model was actually quite complicated or suboptimal in that commercially we would have to design the network. So we would say, we're going to sell you this many switches of this model, this many access points, etc. And the customer signs off. And then you go and look at the site and you go, oh, well, it wasn't quite that. The design's not quite right. We're going to have to go and adjust. And then you find yourself in the awkward situation of saying what you're delivering is not quite what you sold. Do we have to recontract? It's a mess. And so we're going down the path now of saying, we'll provide you this service quality, and this is how much it costs per room.
Okay. And so, along those lines, one of the things about these networks is you're deploying networks that you're not swapping out every year, every 2 years, every 3 years. You're looking for, and I'm putting words in your mouth, right? You're looking for equipment that you can put out there that will stay in place for 3 to 5 years. Regardless of technology cycles, you want something that's going to be reliable and dependent for that long. And the thing that I like about what we're doing on the open Wi-Fi side of the team is that there's a lot of things that help with that investment. what are your thoughts on the longevity of equipment when you deploy and making that 5-year commitment to anything that you install, since it's going to be yours that you're going to
I have some bad examples, sorry. I was on a site, visiting a site. It was a new partner who was doing the install. I was visiting the site. It was in southwestern France last week. And they took out the previous access points that had been there since 2008.
I've stayed at that hotel.
This equipment is not designed to be used for 14 years. It was still working on 802.11g, 2.4 gigahertz. It was still, I mean, it was crap, but it was still working. So the equipment had lasted, but obviously it absolutely didn't meet the requirement.
But along those lines, if I'm the customer and I'm paying you to give me the latest and greatest features, you're my network service provider. It's your job to make sure it's up to date. If you're putting in equipment and they're expecting that from you, being, I'm leading you here, right? It's if you've got a closed ecosystem where it's very difficult to get changes made and things like that. What are the problems that you see when people look for new innovative technology, but you're stuck with someone and you leave it there for 10 years or 12 years or whatever it is?
I think there's a clear expectation from the customer who's got the access points, been there for 14 years. They don't expect wonders. It's just taken them a long time to persuade their investor to stump up the cash to renew, but they don't expect much from it.
Okay, so then you would say, like, regardless of all of this, regardless of you say there's no barrier of entry to Wi-Fi. Anybody can get cheap Wi-Fi. What are the problems that you see are being solved recently? Is there anything that you've seen that's making good Wi-Fi more accessible? What are the lights at the end of your tunnel?
Well, I think OpenWiFi is one of the lights at the end of the tunnel because it is enabling us to deploy within the budget expectations of customers something that works and adheres to design principles we believe in.
And then from your perspective, thanks for doing the live the live show of all the the demo up there, and it's great. It looks good, and again, you bring the cost down for this. What's your incentive to help a group like OpenWiFi? With the plans that you have, and what in the future? What are your thoughts on helping innovate the design and engineering side? Regardless of regular Wi-Fi, open Wi-Fi, where's your head at when it comes to this, and why are you doing it?
Well, that's a manifolded question and answer, but I think it's also about, as cliche as it may sound, it's about doing the right thing. Just like Open Wi-Fi is doing a lot of the right things for the industry. Open roaming, doing the same thing, like improving connectivity for everybody. So it's for us, also the standardization bodies like Wi-Fi 6E has massive potential to make Wi-Fi a lot better if we just design it right and all of that. So it's, the way I see it is all of us are kind of, rowing the boat to the same direction. And that's when magic will happen.
So, you and I have been in a lot of shows together, and one of the things that has been incredible, and I know I've been on the upside of it. I know you're on the upside of it now with Hamina. The support from the wireless LAN community is unlike anything in any community that I've seen I've been a part of. And if Wi-Fi is something that you like and that you're involved in, I would strongly encourage you to reach out to people that are in the industry and become a part of it, because it's like a family. And we've seen product and service after product and service just excel when the community gets behind it. And I think that's where I love to see this crossover, where you've got a user base of beta testers that is those 200 CWNEs in the world who are helping you make your product that much better. I love that's a thing that we do, and I can't wait to see us get behind OpenWiFi to solve the problems that everybody's facing. So I would encourage everyone, if you get a chance, if you want to contribute to it, it's a phenomenal initiative to get behind. I love the tool set that you've built, and I hope that the tool set can help you with better Wi-Fi in your guest rooms. And And I think we have a few seconds left. Does anybody have any questions out there? Yeah, go ahead. I don't know if the mic works, but I will repeat your question.
Yeah, absolutely, absolutely. That's a really good question. So the question was like, could we utilize APIs to determine not only how it was designed, but how the reality looks like? And that's exactly what we'll be doing with Open Wi-Fi. And many of the Wi-Fi infrastructures today are cloud-based and Open API-based. And Open Wi-Fi is kind of a prime example of that. So that's exactly what we're doing right now, is developing also the feedback loop where we actually suck in all the data, telemetry, RF data, RF configurations, and then showing the actual situation as well.
So that could be essentially a bolt-on for anybody's Open Wi-Fi controller to see what real status is? Or?
Yeah, and I'll lead this one a little bit. If you go upstairs and you see our demonstration network for Open Wi-Fi, and I would encourage you connect to the Open Wi-Fi SSID. What we have is right now we're doing it with two separate tools. So or three separate tools. We've got Hamina that we did the design in, and we can use that coming up soon. This is something Jussi wanted to show off here. If you look down at the bottom, where you can do the design inside the tool itself, and then click a button and push all of the design elements out to Net Experience, which is the tool we're using upstairs from a configuration perspective. And then once it's out there, what we're doing is we're sucking in all the telemetry using the Kafka stream from the access points in Net Experience to a tool called WaveSpot, sits in the back. And we've got that on display upstairs to show you where people are and what the environment looks like. We've got a full circle solution here, because then you can even pull that back into Hamina in the future so that you can see in your single source of truth what's happening. The next leg up there that we're showing off upstairs as well, just to kind of get your head in something, in a different area, is then what happens when you take that and you put it into VR? And what happens when you take that and you put it into augmented reality and you use metaverse for work purposes? Now we're talking about ways that you can leverage headsets. You can leverage Oculus and VR and Oculus Quest Pro to do augmented reality. We've got a really cool demo of that upstairs, because it's people like UC, it's people like Sid, it's people like the guys at Net Experience and EdgeCore. That's what makes Open Wi-Fi so cool. Is this isn't the AP subsystem from 12 years ago. All of this is being built on open communication and open access. And one of the neatest things I've seen at the show so far is that Net Experience and WaveSpot, who both offer controller options in Open Wi-Fi, collaborated with each other to enable this feature set that we're using upstairs. Y'all, this code is like 4 days old or 3 days old. And it was the collaboration between two partners who are more interested in seeing how we could build a better solution with Open Wi-Fi than they were saying they're focused on, well, what's your volume size? How many are you going to order? How does that fit into my roadmap? This is like, there's a lot of neat stuff that's happening in Open RAN, but we're like a little bit more feisty, and we like to move really, really quick. So in the Wi-Fi space, we do push 4-day-old code, and we see if it works, and we Q&A it on the site, and you know what? It works really well. We tested open roaming 2 nights ago when the code was, it was extremely fresh, and we did it as a live stream on Instagram just to see if we could break it. So there's a lot of really cool things. You mentioned telemetry is one of the most important parts for you. We can pull that live telemetry to make immediate decisions. And by immediate decisions, imagine wearing an augmented reality headset where you can see where the Wi-Fi is as you walk down the hotel room, or the hotel floor, so you can see if it's good or bad. And these things are only possible because of the partners that support that open collaboration. That was a short answer. Do you want the long answer? No. And we're totally out of time, so I apologize for all being here.
That's all right. I guess my question is twofold a little bit. Maybe with the advent of new Wi-Fi standards coming out, 6E and 7, some point in 2023, and the various new knobs that we have at our disposal, multi-link operations and, whatever. How does that impact, one, the design, right? Well, how will that change the design, especially in a kind of brownfield environment where you might have, 5G generation devices, and then all mixed together.
Yeah. So that's a really, really good question. The good news is with 6E and 7, it's mostly about the new 6 gigahertz spectrum, which luckily in most environments it behaves fairly similarly to 5 gigahertz. So if your 5 gigahertz network is solid, which often isn't the case, but if it is, then it's likely that you'll also have a fairly good signal for 6E and 7 and all of that. So coverage-wise, there's no dramatic difference. There is some, and you always want to validate and make sure that it's still okay before you do that rip and replace. But for capacity, that's what makes all the difference. So with 6E, we need to be modeling like how does the capacity increase, and certainly like places like the expo hall, we are running out of capacity. 6E will be solving that little by little, but then it's about client base and client adoption. We only now last week saw the new iPad Pro come out, which is the first device from Apple that actually supports Wi-Fi 6E or the 6 gigahertz spectrum. So it will still take years before we realize that, let alone Wi-Fi 7 and all of that. So it will take years for that to realize, but we need to be jumping on that boat, I think, today. If you're running any kind of high capacity environments, you definitely want to consider the 6E access points, even though the 6 gigahertz radios may not be that used for the next 6 months.
And with that, I know we are totally over time, so I just want to thank everyone who
Thank you, Drew.
came out. You have to yell. You have to start with the yell. You got a Ric Flair. Anyway, thank you for everyone who was up here on the panel. It was fascinating.
Ladies
Enjoy
and
the rest of the
gentlemen,
show.
Drew Lentz.
Jussi Kiviniemi, the janitor.
And Jonathan, the angel.
Anyway, please, yes, make your way upstairs and check out Open Roaming and Open Wi-Fi. Thanks.